Good morning, students. I'm Sangeeta, lecturer in chemistry, branch, general section, working in GPT Narayankhed, semester 1, subject general engineering chemistry, subject code 18C 104F. Our major topic is solution and colloids, and subtopic is colloids. So in last classes we finished the subtopic solutions. Now our last topic is colloids. Let us recollect what we have discussed in last class. So in last class what we have discussed, what is normality and problems on normality. So once again we will revise what is normality. So what is normality? The number of gram equivalents of solute present in 1 liter of solution is called normality. The number of gram equivalents of solute present in 1 liter of solution is called normality. It is denoted by which letter? Capital N. So what is the formula for normality? Number of gram equivalents of solute by volume of solution in liters. When it is in ml, number of gram equivalents by V into 1000, where number of gram equivalents is given by weight of solute by gram equivalent weight of solute. So what is normality? W by GEW into 1 by V in liters. Then it is volume is in ml. N is equal to W by GEW into 1000 by volume. Okay, what are the units for gram equal? What are the units for normality? Sorry, what is the units for normality? Gram equivalents per liter. So, what is normality? What is the formula for normality? And what are the units for normality? And some problems we did in the last class. So, now in today's class we discuss what is colloid. So come to objectives. So on completion of this period, you would be able to understand. So after finishing this topic, you have to understand these topics. So what is colloid? That is definition of colloid. Next, types of colloids. Then industrial applications of colloids. Okay, this colloids very new topic in C18 curriculum and very small topic, just definition you have, then types of colloids and the properties of that colloids. Then you have industrial applications of colloids. So now we see the introduction to colloids. Okay, so introduction to colloids. So as we know, a solution is composed of solvent and solute. The particles of solution, the particles, okay? The particles of solutions are usually either normal molecules or ions. Okay, already in first unit, first class itself. So introduction to solution. So I told what is a solution. Okay, it is a homogeneous mixture of two or more than two components. So what are the two components? Solute and solvent. And these particles of solutions are either normal molecules or ions. Okay, the size of these particles is between 1 and 10 angstrom units. The particle size is how much in solution? In between 1 and 10 angstrom units, which is invisible to our naked eye. That means we can't see with our eye. Okay, this is about solution. Okay, solution is composed of solvent and solute, and the particles are either normal molecules or ions, and the size of the particles is in between 1 and 10 angstrom units, which is invisible to our naked eye. Okay. Then, when substances such as clay or sand are put in water, the particles settle down. So, if you take water in glass and keep clay or sand in water, so what happens? The clay or sand will go and settle down at the bottom of the glass. Okay. So these are called suspensions. So they won't dissolve. They will remain as it is. They will go and settle in the bottom of that whatever you will take. Okay, that tub. So those particles are called, given a name called suspensions because they are suspended in water. So the particle size is greater than 2000 angstrom units. Okay. The first one is solution. So here two components, they are invisible and particle size is in between 1 and 10 angstrom units. Whereas here particle size is greater than 2000 angstrom units. So they are clearly visible. They will settle down at the bottom. Then a colloidal solution is prepared by making use of suitable methods. So how colloidal solution is used? It is by making use of suitable method. The size of the particle in colloidal solution is between 10 and 2000 angstrom units. So here solution is 1 and 10 angstrom and colloidal solution is 10 and 2000 angstrom units, and whereas in suspensions it is greater than 2000 angstrom units. So now you got the differentiation between solution, suspension and colloidal solution. Solution, it is a clear solution. Okay, the particles are very small in size, we can't see with our naked eyes. Whereas in suspensions, so we can clearly differentiate between solute and solvent particles. So they will settle down at the bottom. So its particle size is greater than 2000 angstrom units. Whereas colloidal solution is prepared by using some suitable methods. So how is the particle size? It is in between 10 and 2000 angstrom units. So here we will see the differentiation between solution, suspension and colloid. Okay. So solution. Salt dissolved in water forms a uniform solution. So here to dissolve salt in water, what happens? It totally dissolves. There is no differentiation between that salt and sugar molecules. So that is solution. Okay, then come to colloid. Milk contains butter fat globules dispersed in watery liquid. So milk is an example for colloid. So how milk contains a butter fat globules. It is dispersed in a watery liquid. Okay. Then suspension. Floor suspended in water. So floor suspended in water as a blue cast from light scattering of the floor particles. So when you floor suspended in water, how it will looks like? So like that is the suspension. So this is the differentiation between solution, suspension and colloid. So today's our topic is colloid. So what is colloid? What are the types of colloids? And what are the properties of colloids? And what are the applications of colloids? We will study. So this colloid scatters the light. Okay. So colloids. So definition. The heterogeneous system in which one substance is dispersed as larger particles in another substance is called colloid or colloidal solution. Okay, this is a heterogeneous system, whereas solution is a homogeneous system. That means you can differentiate two components. It is hetero, different system in which one substance is dispersed as larger particle in another substance. That means one phase is having larger particles and another phase is having smaller particles. So that is called as colloid or colloidal solution. One substance is dispersed as larger particles in another substance. That means here also two substances are there. For example, for colloids, milk, blood, smoke, etc. So what are the two substances present in colloids? So in solution, we'll consider solute and solvent are the two components. Whereas in colloid, we will consider two components. They are dispersion medium and dispersion phase. So what is dispersion medium and what is dispersion phase? The substance in which another substance is present as colloidal particles is called dispersion medium. Okay, the substance in which another substance. So in this substance, some other substance is present. So that substance is called as dispersion medium. So dispersion medium is compared to solvent. So in solution, solvent, here dispersion medium, same as solvent. So in dispersion phase, the substance which is dispersed as colloidal particles in dispersion medium. So which is undergoing dispersion, the substance which is dispersing, which is present in dispersion medium is called as dispersion phase. This is same as solute particles. Okay. So in colloid, you have two components, that is dispersion medium and dispersion medium. So whatever the substance is dispersing, that is dispersion phase. In which it is dispersing, that is called as dispersion medium. Okay. So now we will see some examples. First, smoke. So in smoke, solid carbon particles are dispersion phase and gaseous medium is dispersion medium. That means in gas, some solid particles are dispersing. So here gas is the large particle. So that is the dispersion medium. Gas is the dispersion medium and solid particles are the dispersion phase. So these solid particles are dispersing in this gas. So here dispersion medium is gas. Dispersion medium is gas. Dispersion medium is gas and dispersed phase are solid carbon particles. These are dispersed in gas. Then if you take milk, so in milk, dispersion medium is water and dispersion phase is liquid fat. It means liquid fat is dispersing in water. So water is the dispersion medium and liquid fat is the dispersion phase. Then solid in liquid types colloids are called salts. Solid in liquid type colloids are called salts. If solid is present in liquid, so those type of colloids are called salts. Okay. Next, Types of colloids. Types of colloids. So based on the interaction between dispersion phase and dispersion medium, colloids are divided into two types. So here interaction between dispersion phase and dispersion medium. So based on that interaction, colloids are divided into how many types? Two types. Colloids are divided into two types. First one is lyophilic colloids and second one is lyophobic colloids. So now we will see what are lyophilic colloids and what are lyophobic colloids. So first one is lyophilic colloids. So the colloids in which strong attraction exists between dispersion medium and dispersion phase are called lyophilic colloids. So if strong attraction exists between these two phases, the type of colloids are called lyophilic colloids. Okay. So strong attraction exists between dispersion medium and dispersion phase. The type of colloids are called lyophilic colloids. Example for lyophilic colloids: starch, gum, and gelatin. So now we will see the properties of lyophilic colloids. So what are the properties of lyophilic colloids? So first one, these are solvent attracting colloids. That means they will attract the solvents easily. Then these are prepared by mixing the components. How these lyophilic colloids are prepared? Just by mixing the components. If you mix the components, lyophilic colloids will be prepared. Then third point, precipitation of these colloids is easily converted into colloid by mixing dispersion medium. So these colloids are reversible colloids. So what is meant by precipitation? So these colloids may undergo precipitation. That means they will separate. Dispersion phase and dispersion media will be separated. So how again we can convert into colloid? Just by mixing the dispersion medium. If you mix the dispersion medium, then again it will convert it into colloid. So whatever it is precipitating, that precipitation will again converting into colloid by mixing dispersion medium. So that's why these colloids are called reversible colloids. That means colloid is converting into precipitate and this precipitate is again converting into colloid by mixing dispersion medium. That's why these colloids are called reversible colloids. Okay. Then fourth point, these are more stable due to solvation of particles. So these are very stable and are not easily coagulated by adding electrolytes. So by adding some electrolytes, coagulation takes place generally, but they are not coagulated easily by adding electrolytes. Solvation means that is water molecules are adsorbed there. So they are not coagulated by adding electrolytes. Then fifth point, these are generally formed by organic substances of high molecular weight. So they are formed by what? Organic substance which are having very high molecular weight. And sixth point, its viscosity is higher than the medium. So its viscosity is higher than the medium. And the surface tension is less than the medium. So the area, okay, whatever the area is the surface tension is less than the medium. Then stabilizing agents are not required for preservation. So we can preserve these colloids. So we have no need of adding any stabilizing agent because already they are in stable condition. They are stable. So these are the properties of lyophilic colloids. Once again we'll see the properties. First one, solvent attracting colloids. Then they are prepared by just mixing the components, and precipitation of these colloids again converted into colloid by mixing dispersion medium. That's why these are called reversible colloids. These are more stable due to solvation of particles and are not easily coagulated by adding electrolytes. That means surrounding this one, water molecules are absorbed. So when you add any electrolyte, they are not coagulated. So these are made up of organic substances of high molecular weight. Its viscosity is higher than the medium. Surface tension is less than the medium, and stabilizing agents are not required for preservation. So next second one is lyophobic colloids. Okay, lyophobic colloids. The colloids in which weak attraction exists between dispersion medium and dispersion phase are called lyophobic. So phobic means hating. So are called lyophobic colloids. Okay. So here weak interaction exists. There strong interaction exists. So the type of colloids are called lyophobic colloids. Example, gold salt and platinum salt. So we'll see the properties of lyophobic colloids. So lyophobic, so they are solvent hating colloids. So the properties of lyophobic colloids are quite opposite to lyophilic colloids. They are solvent attracting. These are solvent hating colloids. They are prepared by mixing the components, whereas these are prepared by some special methods. Precipitation of these colloids not converted into colloid by mixing dispersion medium. So these colloids are called irreversible colloids. That means when they are precipitated, again we can't convert into colloid by mixing dispersion medium. So that's why these colloids are called irreversible. Whereas there we can convert into colloid by mixing the dispersion medium. So they are called reversible colloids, whereas these are called irreversible colloids. Next, these are less stable. They are more stable. And here they easily coagulated by adding small amounts of electrolytes. So just by adding small amounts of electrolytes, they undergo coagulation. So that's why they are less stable. So these are formed by low molecular weight of inorganic substances. These are generally formed by low molecular weight inorganic substances. There they are formed by high molecular weight organic substances. So here viscosity is same as medium. Next, surface tension is same as medium. Here stabilizing agents are required for preservation. Okay, so these are the properties of lyophobic colloids. These are solvent hating colloids. Okay, these are prepared by special methods. These are irreversible colloids because they are not converted into colloid by mixing dispersion medium. These are less stable and easily coagulated by adding small amount of electrolytes. These are formed by low molecular weight inorganic substances. Viscosity is same as medium, and surface tension also same as medium, and stabilizing agents are required for preservation. If you want to preserve this colloid, some stabilizing agents are added. So these are the types and properties of properties of lyophilic and lyophobic colloids. Okay, colloids classification and their properties. Now come to the industrial applications of colloids. So applications means users. So industrial. So how we use in industries these colloids. So first, in the purification of drinking water. In the purification of drinking water, we use colloids. Then most of the medicines are colloids. So they are using food materials like butter, cheese, milk, etc. are colloid. Then used in tanning of leather. Okay. Then latex is a colloid from which natural rubber is extracted. So you might have studied in your lower classes. Latex, rubber trees. When you cut a rubber tree, you will get a milky liquid that is called latex. That is also in colloidal form. From that latex, what you will get? You will get natural rubber. The rubber which is extracted from trees is called natural rubber. So latex is a colloid, and these colloids are used in photography. Then these colloids are used in cleaning action of soaps and detergents and used in smoke precipitation. Okay, so here there to reduce the air pollution we will use electrostatic precipitator. So there we will using smoke precipitation. The smoke is a colloid. Okay, negative carbon particles are dispersed in gaseous medium. So these are the some of the applications of colloids. First one, purification of drinking water used as medicines. Food materials like butter, cheese, milk are colloids. Okay, then used in tanning of leather. Then latex is a colloid from which natural rubber is extracted, used in photography and used in cleaning action of soaps and detergents, and next used in smoke precipitation. So these are the some of the industrial applications of colloids. So okay, what we have studied today. So introduction to colloids. What is colloid? So colloid is a heterogeneous system in which one substance is dispersed as larger particles in another substance is called colloidal solution. So whichever substance is dispersing, that is dispersion phase. In which it is dispersing, that is called as dispersion medium. Example for colloids: milk, blood and smoke. And these colloids are of two types: lyophilic and lyophobic colloids. If strong interaction exists between dispersion medium and dispersion phase, those are called lyophilic colloids. If weak attraction exists between dispersion medium and dispersion phase, those are called lyophobic colloids. And we have seen the properties of lyophilic and lyophobic colloids. Then industrial applications of colloids. Okay, next come to summary. So in this period, what we have discussed definition of colloid, types of colloids, properties of lyophilic and lyophobic colloids, and industrial applications of colloids. Now, see objective type questions. So, what type of objective type questions you may expect from this topic in your entrance? So, very simple questions and direct questions. Colloidal solution is a mixture of what? A homogeneous, B heterogeneous, C amphoteric, D none. So what is the answer? Heterogeneous. So in definition we studied colloidal is a heterogeneous mixture of dispersion phase and dispersion medium. So answer is B. Then the following is lyophilic colloid. Okay, the following is lyophilic colloid. So here answer A starch, B gold salt, C water, and D all. So all is not the answer. Water is a solvent and from about to. So which one is answer? Lyophilic. Starch is the lyophilic colloid. Then what is the best description of blood? So here, whether blood is aerosol? No. Blood is a solution? No. Blood is a foam? No. Blood is a sol, that is solid in liquid type. Colloids are called, okay, salts. So answer is A, salt. So blood is a salt. Next, when the fourth question, when the tiny particles of a substance are dispersed through a medium, then the mixture is called. So tiny means small particles of substance are dispersed through a medium. Means dispersed phase and dispersion medium. Tiny small particles are dispersing. So then that mixture is called alloys, amalgams, suspensions, colloids. Not alloys. It's a homogeneous mixture of metals alloys. Amalgam means mercury with metal is called amalgam. Suspension means very large particles will be present. So here tiny particles. Same. So answer is B, colloid. The next question is colloids can scatter light, not scatter light, absorb heat, evolve heat. So while explaining colloids, I have shown. So colloids can scatter light. I will show once again here. So here, colloids can scatter light. So answer A is the correct answer. Colloids can scatter light. Let's come to questions. So this type of questions you get from this topic. Define colloid and give example. Define lyophilic and lyophobic colloids and give examples. And write industrial applications of colloids. So among these questions, so this industrial applications important and definition of colloids. And this also properties are not given. Those are not important. No, not important, not like that. So these are important questions and these may ask in your final exam. Okay. So with this, we finished colloids topic. So whatever, if you have any doubts, we will clarify your doubts in next class. Okay. So this is about colloids topic. So if you have any doubts, we will solve those. We will clarify your doubts in the next class. Okay? Thank you, students.